In the last video of this series, I showed you the complete architecture, the blueprint of my local voice assistant, Cal. And I said one of the big milestones was actually getting everything working locally and not relying on the cloud at all. Today, I'm going to walk you through how to set this up and also share the code with you to make it happen. I've packaged up the custom plugins I've made and I put them into a GitHub repository that I'm going to share with you on the newly minted CoreWorks Lab GitHub page. It's called Local LiveKit Plugins, and it's speech-to-text and text-to-speech plugins that allow you to run LiveKit Agents entirely from your own hardware. And by the end of this video, you'll have your own local voice pipeline working on your own machine, along with an example agent that you can use. You'll understand how the plugins work, and you'll have the source code to be able to put it in your own projects. So let's get into it. Before we dive into the code, I'm going to be honest, the cloud models are better. If we look at models like DeepGram and 11 Labs that are hosted through LiveKits, they're just higher quality. They have a huge data center of GPUs that can power these models. They sound better, they're more natural. So why go local? Well, for me, it's privacy. My voice never leaves the machine now, and for a home assistant, for me, that's important. Cost. There's no really recurring costs other than powering my machine for about 20 bucks a year. And the learning aspect. I want to learn how to do this. This is a journey for me, so I'm going through it and learning as I go. And honestly, Claude code is a huge part of that learning journey for me, and Claude has done a lot of the heavy lifting with building these custom plugins. But that's development in 2025, is using AI tools, and it's really helping me to learn as I program alongside AI. And I've been using Claude code for this. I've found Claude to be the best for complex projects like this one, working with LiveKit, and it's been excellent. So the challenge I worked through here was that LiveKit assumes that you're going to use cloud-based models. And I couldn't find any plugins to use for a local setup. And maybe they're out there and I just couldn't find them. But this is why I created my own with Claude. But there is another way you could do this. You could run separate Docker containers in this microservice approach. You could run a speech-to-text and text-to-speech service wrapped in their own containers running in Docker that are exposing OpenAI APIs so that your agent can connect to those with the built-in OpenAI and Grok plugins that are available. This is another way to do it. It's a little more complex because you are managing separate containers and connecting them all together. Now, the approach that I've taken here with these plugins is that there's just 2 extra files that these plugins are written in Python, and then you just reference those plugins within the code. So there's no separate containers. It's all within the single process of the agent. But there's pros and cons to going each way, but this video is about putting it all into a single process. So back to the GitHub repo. It's called Local LiveKit Plugins on the CoreWorks Lab GitHub page. And it's running FasterWhisper for speech-to-text on GPU and Piper text-to-speech on CPU. Now, Piper is actually performing better on CPU than GPU in some cases. And that's because of the overhead and the way the code is written. There's a whole discussion on the GitHub page for Piper if you want to look into that. But FasterWhisper is running on GPU and Piper is running on CPU. And this has all been tested on my current system, which is running Arch Linux on an NVIDIA RTX 3060. If you're on Windows or Mac, I haven't tested it on either of those OSs. Try it out. You might have to make some tweaks. We'll see if we can work together on getting that working on all OSs. So let me show you how to get this running now. I got a demo folder that I'm going to put everything into. And the first thing we want to do is clone the repository and CD into the folder that it gets cloned into. So now we're into local LiveKit plugins on the main branch. And then we run UV-sync to pull up all the dependencies. So mine were already cached within UV cache, so it pulled really quickly. but it's about a gig worth of downloads here with PyTorch and some other pretty big packages. Then the next thing we want to do is download the voice models for Piper. So we can copy this whole block of code here. It's going to create a directory for the models and then move into that directory and download the models. So let's run that. Okay, they're downloaded. And now we run a Docker for the LiveKit server and then check if it's running. So mine throws an error because my LiveKit server is already running with the same name, but this OK is from the curl command checking to see if the server is up, and it is up. Next thing we want to do is get the configuration. So we copy this examples environment variable file into our own environment variable file, and we'll go back to the main folder and run that command. And then we'll clear the screen and we can open up that file to see what's going on in there. So this has your LiveKit server connection on your local host. You don't need API keys, so just put whatever you want in here. This is if you want to test out Cloud. If you have a Cloud project you want to connect to, you can set that up here and then select whether you're running local or Cloud right here. So we're going to run local. And for the local pipeline, the Whisper model we're using is medium, using CUDA. That's the GPU device, but you could set this up as CPU as well. The Piper model path is defaults here to the high quality Ryan model. You can go to this URL here and download different models if you want to do that. And Piper is false for using GPU. We're going to run it off CPU because it's actually faster doing that. This assumes we're already running a Ollama. If you're not, just run Ollama serve command, assuming that you have it installed on your system, and change the model if you'd like to run a different model. We're going to use Llama 3.1, 8 billion parameter. And then down here is for API keys for the Cloud pipeline, but we're using local. So we can get out of there, clear this again, and now we can start up the agent. And we run this line here to start up the agent. Okay, and we can start up a system monitor here to monitor what's happening on the GPU and CPU. And we'll make the response time a little faster here. And then we'll start up the agent. And this is all in real time. Hello, how are you?
I'm doing great. Thanks for asking. I'm here to help with anything on your mind. How about you?
I'm good, thank you.
What brings you here today? Need any assistance or just want to chat?
All right, we'll close that down. Very friendly fella. And you would have seen the GPU and CPU spiking here. We got the speech to text Whisper model running on GPU, as well as the Ollama model. And on the CPU, we have the text to speech Piper model running. So great, we got a fully local pipeline running with the example agent. Now let's look at how it works. First, let's open up the FasterWhisper plugin. Okay, you can see we're importing the Whisper model package directly. There's a lot of commenting in here if you want to read through that. But basically what it's doing is it buffers audio until we stop talking. It runs that through the Whisper model to make a transcription, combines all those segments into a final text, and returns that to the LiveKit server. The key settings in here are the model size, the device we want to use, CUDA or CPU, and the compute type, so float 16 for GPU or integer 8, int 8 for CPU. That's basically about it. Now let's look at the Piper plugin. The Piper plugin is similar. We got some key settings here within the init, whether we're using CUDA or not, so GPU or not, we are using CPU, so it's false. You can change the speed, the volume, the noise levels, and then it just synthesizes the speech from the text and then chunks that and returns that to LiveKit as well. And finally, let's look at the agent, how we pull these into the agent. So in the agent code, This is where we pull in those local plugins. So from the local LiveKit plugins, we import FasterWhisper and Piper. And then we also pull in the environment variables that we set up earlier. So the model size we want to use, the device, the voice model that we want to use for Piper. And down here within the agent, this is where we use it all. So we use FasterWhisper, we use the Olama model, and we use Piper. So this TTS and STT, these are the custom plugins that we're using. That's what we replaced the cloud models with, is these local plugins. And this is the key right here. This is where the agent uses it. And that's about it. You can do exactly what I just did, following the README from the GitHub repo right here to try to get that example agent up and running on your system. If you want to use these plugins in your own project, you can add the source to your project like this, and then within your project, add the import statement here, and then use those custom plugins just like this. It took me a little while to figure this out, how to get LiveKit working with a completely local pipeline. Hopefully this helps you in your project. I'm going to be releasing more code from my voice agent Cal in the coming weeks, so hit subscribe if you want to see those. And otherwise, thanks for watching, and I'll see you in the next one.